Hello viewers, subscribers, students, and future engineers. Here are another problems in stat trigonometry, solutions to triangles 4. Solve the triangles with given elements using only the law of sines. So we have these sides here. There are 4 problems. So by sine law, that's our guide. A as to sine angle A equals 846. 431 as to sine angle A equals 846 as to sine 116.4 degrees. This is the guide formula by sine law. So 431 over sine angle A equals 846 as to sine 116.4 degrees. So sine angle A is 431 sine 116.4 degrees over 846. And using your calculator, inverse sine of this quantity here, we'll get A equals 27.15 degrees. Since A is shorter than B, and side B is 846, which is longer, and the side opposite it is obtuse, so it is impossible that A has an equivalent obtuse angle. So it is already fixed. There's only one triangle because side A is short and B is already long, and that's why opposite to side B is an obtuse angle 116.4 degrees. So in a triangle, the sum of the interior angles is only 180. So if one is obtuse, that's the only obtuse angle. Having found A, we can now solve angle C, which is 180 degrees minus 27.15 degrees minus angle B 116.4 degrees. So angle C is equal to 36.45 degrees. And that's also the fixed angle because one of the angles, interior angles, is already obtuse. So no interior angle can be obtuse at the same time with the other 4 triangles, because the sum of obtuse angles is already more than 180 degrees. So having found angle C, we can now solve side C. C as to sine 36.45 degrees equals 846 as to sine of 116.4 degrees. So side C is 846 sine of 36.45 degrees divided by sine 116.4 degrees. So side C is equal to 561.1 units. So these are the elements. Let's proceed to B. So given side A and angle A, to find angle C. So C, it is 3.7 as to sine angle C is equal to 54.0 as to sine 43.6 degrees. So sine C is 83.7 times sine 43.6 degrees over 54, and it is equal to, it is more than 1.069, more than 1. Therefore, sine, cosine functions cannot be more than 1 by definition, because sine is opposite over hypotenuse. It's the hypotenuse that should be the longest. The only possible way for sine and cosine functions to be equal to 1 is when the angle is 0 or 90 degrees. For sine 90 degrees, for cosine 0 degree to be equal to 1, but those sine and cosine functions cannot reach beyond 1. So therefore, there's no such triangle for this situation. Then for C, it is side B and angle B given, and side C given. So C as to sine angle C is equal to 3.562 as to sine 50.23 degrees. So sine C is 4.21 sine 50.23 degrees over 3.562. So using your calculator, C is 65.29 degrees. So let's study if it is possible that there is an obtuse angle equivalent. Remember, sine of an angle is equal to sine of its supplement, sine of 180 degrees minus the angle. Since C is longer than B and B is acute, so there's a possibility that the other value of C is the supplement of this 65.29 degrees. So C prime is 180 degrees minus 65.29 degrees, and that is 114.7 degrees, or 114.71 degrees. So let's concentrate first on 65.29 degrees. Let's solve for angle A, which is 180 degrees, minus angle B, 50.23 degrees, minus 65.29 degrees. So angle A is 64.48 degrees. Then let's solve for side A by sine law. A as to sine 64.48 degrees equals 3.562 as to sine of 50.23 degrees. So side A is 4.182 units. Having found side A, we can now solve, we can now complete the solution to the first possible triangle, which is A is 64.48 degrees, side A is 4.182, and angle C is 65.29 degrees. Then for the other possibility, C prime is 114.7 degrees. Let's solve for angle A prime, 180 degrees minus 50.23 degrees minus 114.7 degrees. So A prime is 15.07 degrees, so which is possible. Then let's solve for side A prime. So A prime as to sine of 15.07 degrees equals 3.562 as to sine 50.23 degrees. So A prime is 3.562 sine of 15.07 degrees divided by sine 50.23 degrees. So using your calculator, A prime is 1.205 units. Then for side A prime. So we have completed the solution for the second possible triangles. So A prime 15.07 degrees, side A prime 1.205 units, and C prime 114.7 degrees. And finally, for part D, 4D, so it is B and angle B given. So let's solve for angle A, 859. So A is longer than B, and B is already an angle which is close to 90 degrees. So from this given data, we can anticipate that maybe there's no such triangle because the value would be greater than 1 for sine angle A. So, but anyway, let's just apply sine law. So 859 as to sine angle A equals 783 as to sine 74.3 degrees. So sine angle A is 859 sine 74.3 degrees divided by 783. So using your calculator there, sine angle A is greater than 1. So again, when sine of an angle exceeds 1, then there's no such triangle possible. So that's it for this problem. I hope that because of the so many examples, you can now solve triangles in general. You can tell if there are two triangles, one triangle only, or there's no such triangle?